Guys, what is going on? Welcome back to the shop. Today we've got a couple of updates on the Tumulisa build and just a couple of fun tidbit things to learn along the way as we try to build a foam board airplane from balsa plans. All right, so right off, I want to get into some meat and potatoes kinds of things. There's lots of different wheels you can get on the market. Dubro makes some really great vintage wheels. But again, we're trying to stick to the flight test kind of thing. And these are 3D printed. 3D printed meaning, yes, everything is 3D printed, including the squishy tires. This is TPU and this is PETG. I've got a little piece of styrene tubing that I use for centering that I can push out or drill out. I don't know what I'm going to use yet because I haven't done the landing gear wire yet. So one thing at a time. But I wanted to point this out because, again, we're trying to stick to the theme of flight test style and being self-resourceful. So this is one thing that I did because it's in the spirit of flight test. Yeah, I could just as easily buy the ones from Dubro. I didn't. Okay, moving on. This is the bottom wing plan. Okay, so a couple of things I want to note here. Number one, we have the original slot like we did on the top wing that corresponds on the bottom wing as well. So that's what this is for. Okay, I've covered that in the previous video, so I'm not going to go over it again. The other thing is we needed a provision for our ailerons, and that means an aileron servo. So I did what any good flight tester would. I put down a servo about where I thought it should go, and I traced it, and I cut it out, and it worked. I'll show you guys here in a second, but it's really as simple as that. You don't have to make things harder than they need to be. So I didn't. All right, so obviously we've got a hinge line. Again, reading these balsa plans, usually a hinge line corresponds to where two pieces of balsa sit, and there is a center line. So that is this line, and it extends all the way out to here. Okay, so that's our hinge line. So that's where we can mark on the foam board. And so initially, I made this quick and dirty cut, mostly because I was trying to figure out a couple of simple things like, do I remove the paper backing on the bottom or just the top, or how much of a problem is this really long aileron going to be? Because again, normally you don't have ailerons on these World War I airplanes that extend the entire length of a wing, but it does on this one because there's no aileron on the top wing, only on the bottom. Again, Swedes do things a little bit differently. The other thing that I had a problem trying to figure out without going to a computer was, if I do an airfoil shape, how long does the bottom need to be, or how long does the top? So what I did was I just assumed that this top view on the plans was going to be the top of the wing, the curved part. It's easier to do it that way because the bottom part you can just cut it. So I figured after I made my airfoil shape, we need to cut off about 1/2 centimeter. It's about 5 millimeters. So that's what I did. That's seriously the simplest way that I could think of doing it. And this is exactly what I did on the top wing, sort of. If you recall, I tried using a reference line, but I didn't measure anything. Like, I didn't measure to see where. So this is where I planned for it to be. Where did it actually land? I didn't care. So let me get the wing set on the bench, and I'll show you guys some more detailed things about this. All right, so first of all, you're going to notice that, yes, I'm using 3D printed control horns. Yeah, because I have a 3D printer. And yeah, I could use the ply ones, but I didn't have any, and these were easier. So the other thing you'll note is that I have this bend. And this is a fun little thing that I picked up on a couple of years ago when I saw a smaller build, is that because I don't have any specific hardware on either end here, I need a way to possibly adjust the length of the control rod. So this bend, this Z-bend here, large Z-bend, I can increase or decrease the length of the rod based off of those bends. That's what that's for. Again, simple, cost-effective, it works. All right, so it's also a short enough control rod that it's not going to matter much if it bends a little bit. If it were longer and flexier, you'd want to go to a thicker control rod. Just some thoughts moving forward in case you're thinking about applying this for your specific model. So, moving on. Again, going back to what I was just talking about in terms of how long to make this bottom piece, you can see there's just a tiny little overlap here, but it's not enough to interfere with the deflection of the aileron. So, we're good there. Now, this is clearly longer than 30 centimeters. So what did I do for this spar? So technically it's not a spar. I want to make that completely clear. It is not a spar because it is not a load-bearing structure. It is simply a spacer. It is a piece of foam put in place to create a shape. The strength of these foam board models doesn't necessarily come from structure. It comes from the paper tension. And it's a good thing and a bad thing, right? So the paper is really resilient stuff, and it's bonded really well to the foam. And so it acts like this skin that distributes the load throughout the foam. It's really quite awesome that it does this. But, you know, for what I'm doing here, I don't really need a spar per se, because the paper over the entire wing is essentially a spar. So why do I have it go this long? All right, so there's a fuselage that sits in here, and we'll get to that in a second, but that's what I wanted to point out. The fuselage will sit here, and then we will glue this into position once we get it finally mounted. This is simply a piece of foam to hold it in place, because it's really twisty and flexy. Okay? So, don't think that I'm crazy and thinking that that is going to hold the airplane together. It's not. It's not. What it's going to do is enable me to assemble the airplane and let the glue and the paper work together to do their job. Let's move along. So the big progress this week has been the fuselage. All right, so a couple things to go over here. Single flat plate for the horizontal stabilizer elevator and vertical rudder. So with the elevator, I did initially cut this out thinking, oh, I'll just put a piece of barbecue skewer here. Didn't really work out that well. The barbecue skewer was interfering with the hinge and deflection point. In the end, it's not terrible that it's this way. Could I have gone back and cut a new one? Absolutely, but I was lazy. Again, I'm trying to push through this build as quickly as possible, keeping things simple. It's not a huge deal. It's not like this airplane's going to be a super speed demon and you're going to be worrying about too much deflection of the control surface. There's any number. I've heard them all from you guys. And it just doesn't matter on this slow flying airplane, okay? So, again, we've got the same 3D printed control horns. I did add an additional piece of, what's it called? Hinge material. There it is. This CA style hinge material. I put a small piece just below in there just to have something so that stays attached. And you can do like a piece of paper that is extended out and fold that with hot glue, like put it onto the fuselage with hot glue. I didn't want to do that because it's not necessarily a a great solution because I have seen paper wear out on those particular joints. So I wanted to go with something a little bit more robust, a little bit more familiar to me, but also something that I can share with you guys because it is something really simple that you can pick up at a local hobby store. Local hobby store is probably going to have some of this, but you can also do makeshift materials like old floppy disks. I've got floppy disk material from floppy disks that I've taken apart, and that stuff is amazing for hinges, okay? So you can just make things out of for hinge material, okay? So that's the point I'm trying to drive home. I did use a Dubro micro pull system for the tail, for the rudder, just because, well, I gotta save weight. And the tail weight is, okay, so right here I'll insert a picture or a couple of pictures, okay? So the tail sensitivity of this model is severe, okay? With just the fuselage as it was built and then putting the horizontal stabilizer, just the horizontal stabilizer is the difference between really nose heavy and tail heavy. Okay, just in terms of how it sat on the table, right? So again, save as much weight in the tail as you can possibly stand. And so that's why I went with the micro pull system. Worth the investment, worth the time. Dubro's got a Dubro 101 video on how to install pull systems, teaches you the basics. Again, super easy. Take your time, be methodical, it'll work out fine. Going back to the tail, we've got just a standard push rod for the elevator. And again, we're just poking holes in the foam. Nothing, we're not even using like guide tubes or anything. Really simple stuff. Moving on, so we started with just this aft portion of the fuselage. I covered up with some of this paper rather than foam board, again in the name of keeping things light. Up front, what we're dealing with here is a deviation from the flight test stuff. So again, no power pod here for a number of reasons. Number one, I have an actual thrust line, okay? There's some right thrust, and it's kind of hard to tell in this vantage point, but there is some down thrust, all right? Really important for these models to have the right thrust line. I can't stress that enough. So I wanted to make sure that I built the motor box per the plans and get the right thrust line. So I did use 1/8 inch ply. This is not, you know, high grade 5 ply. It's standard 3 ply stuff. It's simple and effective. We're not talking about a tremendously overpowered model here. It's good enough for the job. I've got some scraps of balsa just to do some reinforcements, and some CA glue, and that's it. Nothing complicated. Built per the plans, and then I added a piece of foam behind. This is a piece of scrap 3/32 ply, because I didn't have any more of the 1/8. Again, being resourceful, but sticking to what the plans call for, because I needed a robust mount for the engine box. I'm not going to just hot glue the engine box to, like a wood engine box, to a foam firewall. That doesn't make sense to me because, again, how critical the thrust line is. If there was any sort of nose over, instantly that thrust line is going to be changed. All right, so it needed to be more solid than that. Moving on, the other reason that I had to have this box here is I needed to have a directly clean back of the firewall. Why? Because I can fit a 5800 milliamp hour 3-cell right here and my ESC right here. Why? That's right, ballast, because that allows me to offset the weight of the tail as far forward as possible, because right here is going to be a round cowl. Okay, this is the point where I can fit as much weight as possible, usable weight, without going too over the top. All right, so those excuses out of the way. Moving on, we're going to flip this over and talk about the guts. So we've got our pull system on a 9-gram servo. We've got our elevator on a 9-gram servo as well. And I'm using literally paint sticks. Paint sticks. Okay, cutting the paint sticks, Josh has shown how to cut them cross grain. Cutting them with the grain is even easier. All right, just straight lines, do a couple of light passes, done. This stuff is super easy, and then you just smear glue around to help it reinforce on the sides, and it's fine. Like, it's not going anywhere. Now, the landing gear plate is in the other story. All right, so you can see down below there's a piece of paint stick there and a piece of paint stick there. Now, the way that you mount the landing gear per the plans is there's a wire here, and then there's a loop of like plastic that goes over top of that to hold the wire in place. I needed a rigid structure that the foam board was just not going to handle. So I'm using common technique, common material, simple building, and I increase the hard point surface area along the side of the foam, because if we take a hard impact here, it's going to start crushing the foam. So again, using the skin as a tension and structural part of the aircraft, we are transferring not just the load to this immediate point, but to the skin around it as well. I hope that some of this stuff is making sense to you, and I hope I'm explaining it well enough. Now, obviously, these kinds of building techniques are very familiar to me, but I understand that I'm presenting it to someone who may not be familiar with it. So, leave a comment in the video description, or in the link in the description, there is a link to a build thread on the Flight Test Forum. Highly encourage you to go to the Flight Test Forum. It's a great resource. Lots of really great friendly people where you can openly ask questions and not be, well, you didn't use the search bar. We're going to answer the questions. We're going to help you along. And I want you to ask questions because I don't know what you don't know. And so by asking a question, by voicing yourself, you help me help you. That's it for today, guys. Thank you so much for coming to the shop and seeing the progress on the Tumolisa. I hope you can use these techniques yourself and make something absolutely stunning for this event at Flight Fest 2022. It's going to be a great year. Until next time, guys, keep working on your flying foam works of art.